Okay, so
You look too happy.
this one is, again, finding a derivative. There are, how many different terms are there? How many different terms does f of x have? How many different terms? 3 terms. 3 terms. Where are they? I'm going to highlight them for you. If you don't see it, I'll highlight them. The first one is e to some power. The next one is positive 6 to some power. And the last one is a natural log of something. Okay, there's 3 terms. They're each joined by plus, right? Plus sign. So if they're joined by plus sign, do we need to use product rule or do we need to use quotient rule for them? No, we can just it's just 3 separate problems into one. So that's how we're going to do it. Okay? Okay. So let's focus just on the yellow right now. Let's focus just on the yellow. Okay.
It's like e something times the derivative of the exponent, right?
Where is it? Where is it? Okay, so here we go. Okay, so what is the rule? It's E. It's an E problem, right? Even though it has tangent up there, I'm not really dealing with tangent. It's not a tangent problem. It's an E problem with a tangent in there. Okay? So how do you find derivative of anything E to a power? What's the first step?
Rewrite.
Rewrite. So let's rewrite it. E tangent 3x. And then what do you do next?
Derivative of the exponent.
Derivative of the exponent. Now to find the derivative, to find the derivative of the exponent, I'm going to have to use the chain rule because 3x is inside of tangent, right? Yeah. Okay. So to use the chain rule, first thing we're going to do is find the derivative.
It's like a negative secant or something, right? Or the secant squared.
Secant squared.
There you go.
Negative secant squared or normal secant?
Positive.
Okay.
So we're going to find the derivative of tangent of something, right? So tangent, derivative of tangent, secant squared. Oops, wrong color. Secant squared, right? Rewrite it. And then now we got to find the derivative of the inside, right?
Might be 3.
Which is just 3. First problem is done. Okay? First problem is done. You probably put the 3 in the front. You can't, you probably will see it with the 3 in the front. 3 times E tangent 3x times secant squared of 3x. You'll probably see it like that. That's probably a better way to do it, but okay, so that's the derivative of the yellow. So now let's do the green. So green is something that we haven't seen since the first page, right? It's an exponential, but it's not an E-based. It's rare that you see one of these, but you will see them sometimes, right? Most of the time they're exponentials, it'll be E something. But sometimes it will be something else. So right now it's 6 is the base, right? 6 to some power. Okay, so let's go back to the front page and see what the rule is. Okay. So the rule said if you have an exponential, anything to a power, right? Start with the natural log of whatever the base is. So what is the base? 6. So it's going to be natural log of 6 times, what is this guy?
This same one.
Just repeats itself, right? This is just repeating. Times the derivative of
Exponent.
the power, the exponent, yeah. Okay, so those are the 3 things we're going to do. Okay. So the first thing again was natural log of the base, right? Natural log of the base. So natural log of 6 times, rewrite it, right? Rewrite it, 6 to the x squared power times, and then what was the third part?
Derivative of the exponent.
Derivative of the exponent, which is just 2x. So I can't multiply any of the 6's times 2 because 6 has a power and 1/6, and one of the other 6's is a natural log. So how can I write that the best way? Just 2x times the natural log of 6 times 6 to the x squared. That's the best way to write it. Okay. Last one. Natural log. This is a natural log problem, right? So how do we find, what's the first thing you do when you find derivative of anything with a natural log? Fraction, right? Good. Fraction. What goes on the bottom? Rewrite, so it would just be secant of x, right? What goes on top of the fraction? The derivative. What's the derivative of secant? Yep. Repeats and then times tan.
Because I need to remember it.
Right? We're going to use them enough where you guys won't need to remember it. You'll just know it. Okay? Especially the big ones. Especially the ones we use a lot. Sine, cosine, tangent. Secant we use. Cosecant is cosecant and cotangent are those ones that once in a while they'll appear, but mostly it's secant, tangent, sine and cosine. Okay, so what can I do there? You notice anything I can reduce? Yeah, right? I can divide them both by 1, cancel them out. So that just becomes tangent of x. You are done. That's as far as we can go. We leave them.
Oh my goodness.
Still 3 terms. Still 3 terms. Because I have 2 plus signs. So there's only still 3 terms, but, it's a little more extensive than it started. Okay? All right. Okay, here we go. Example number 5. Yes. The reason I like derivatives of e's and ln's, it's not that hard, right? It's not that hard, but when you're done, it makes you look very smart, right? It makes you look like you did something a lot more, right? Exactly. Right? It's one of the easier things we find derivatives of.
I remember the space part so high. I was like, why is my palm so big?
Right, you don't understand what goes single thing without your little head.
It's
all for the brackets.
No, it's for the brackets for you.
Okay, I'll start using
Holy
highlighters
shit.
now.
Look how
Why
fancy,
not?
you can see exactly what I'm doing. You
Okay.
See, this one, I have no idea what's going on. 'Cause I
Okay.
can highlight anything.
All right, so let's do number 6. I don't know what happened to number 5. Don't ask me what happened to number 5. Number 6.
I left all my signs in there for you.
Okay. All right, so what's our first step for this problem? Read the question.
Oh, yes.
What's the second step then?
Derivative.
Yeah, I don't see anywhere where it says f prime, y prime, derivative. Where do we get how do we know we need to find derivative? What are the
Tangent line?
equation? It's not slope, right? But still, don't we need a slope to make an equation?
Like y minus something. Wait, no, we have the code.
Right?
It's y minus 4.
Yeah, and then the equation that's easiest to use is this guy here. Y minus y1 equals mx minus x1, right? Is that the only line equation of a tangent line? No, but it is the easiest one to use. So we need a point, which we already have, right? And we just need a slope. To get a slope, you need derivative. So we're going to find y prime. So how many terms does this guy have? 2, good. 2. One guy here, one guy here. They're joined by a minus sign.
Okay, thank God.
Okay? Once you can do that, that's what when I'm doing these problems, like when I'm doing checking work or I'm doing these problems, that's one of the first things I do. Because that's the biggest thing I find is if they're 2 different terms, it's really 2 different problems just combined together, right? As opposed to a product rule problem, which is really 1 problem, right? So this guy is 2 problems. Okay, so first thing is the derivative of 4x squared. What's the derivative of 4x squared? 8x. Done with that one.
Thank
Now the yellow.
Goodness.
Minus. How do we find derivative of anything with a natural log?
Fraction.
Fraction. What do we put on the bottom?
Rewrite.
Rewrite. What do we put on top?
Derivative.
Derivative, 4x, right?
Yeah.
That's the derivative.
One.
Plug in 1, right? Or actually, yes, plug in 1,
It's 6.
and that'll give us our...
Can we subtract the 8x and the 4?
no, because they have different denominators.
Oh.
This one's denominator is 1. Yeah, it'd be nice if we could, but yeah.
Would have been very nice.
So plug in
I think it's
x,
6.
right, to the derivative, and that'll get you the slope. So 8 times 1 minus 4 times 1, 2 times 1 squared minus 1.
And that's 4.
So we get 8 minus, what'd you guys get? 4 over 1?
I kind of forgot that 1 right there.
So that's 4. Okay, so let's write y
So 1
minus
4 equals
4 equals the slope, which is also 4, x minus 1.
Yay!
This is the type of question you're more likely to see on a free response.
I'll take that.
Free response is the questions where they ask you to put find the equation of the line, or find the slope, or stuff like that. That's usually where free response questions go. If it's just a straight find the derivative, if they just said find the derivative of something, that's more of a multiple choice question. Okay? That's how to tell the difference between the two. Okay? All right. Okay, so